Okay, welcome everybody. This is already week 2 of the answers to the extra exercises in the assignments. I hope you managed to make all of them in week 1, and let's continue with the ones in week 2. Okay, week 2, linear algebra exercise 8. So we have two equations, 3y minus 2x equals 5 and minus 3x plus 2y equals 8. And this p is some unknown value. So what is the coefficient matrix of this system? So the coefficient matrix, let's call it M, would be the values in front of the x and the y. And then mind that the first one is in the wrong shape. So we should first change this one in minus px plus 3y equals 5. So minus p 3 and minus 3p. So the coefficient matrix of the system is minus p3 minus 3p. Okay, question B. Give all the values of p for which this system has no solution. Okay, then we need to remember that a system doesn't have any solutions if the determinant of the system is 0, because then we cannot calculate the inverse matrix. So what is the determinant? That was the left diagonal minus the right diagonal. So minus p times p minus 3 times 3, so that would be plus 9. So that means that p squared equals 9. So p is either 3 or, don't forget this one, p is minus 3. So in this case the determinant doesn't have a solution. The system doesn't have a solution. Okay, so for the rest of the exercise, exercise C, determine the inverse of the coefficient matrix C. And then they say replace the value p with 2. So if we think about the coefficient matrix again, so that would be minus 2, 3, minus 3, 2. And so now we've replaced the p with the value 2. What is the inverse matrix? So that would be 1 divided by the determinant. Okay, what is the determinant? That would be minus 2 times 2 minus 3 times 3. So that would be minus 4 plus 9, it would be 5. And the inverse matrix is then 1 divided by the determinant times the left diagonal switches places, so we have 2 there and minus 2 there. The others stay as they are, only the signs change, so this becomes a minus and this becomes a 3. So the inverse matrix would be 1 divided by 5, 2 minus 3, 3 minus 2. Okay, D. Calculate the intersection point of the two lines using this inverse matrix. Well, let's first calculate the intersection point by using one of our known methods, elimination method or the substitution method. So let's put them underneath each other in the correct shape. So minus 2p plus 3y equals 5 and minus 2p, minus 2x, and minus 3x plus 2y equals 8. Well, to get them in the same shape, then I'd have to multiply them. And to make them identical, we multiply this one with 3 and this one with 2. Okay, then we get the following set of equations. So minus 6x plus 9y equals 15 and minus 6x plus 4y equals 16. Okay, now we can subtract to get rid of the x. So if we subtract, then this becomes 0. 9 minus 4 becomes 5y equals 15 minus 16 minus 1. So that would mean y equals minus 1 divided by 5. Okay, then we have to calculate what x corresponds with that one. So let's use the first equation to do that. So minus 2x plus 3y. So minus 3 divided by 5 equals 5. So that means we have minus 2x being 5 plus 3 divided by 5. So that's 25 plus 3 is 28 divided by 5. So x would be minus 14 divided by 5. Okay, so now we have calculated an intersection point, and let's try to do it with the inverse matrix. So we have the inverse matrix given by m minus 1 being 1 divided by 5, 2 minus 3, 3 minus 2. And we know we can calculate the intersection point by using this inverse matrix and multiplying this one with the values of the equation. So multiplying with 5, 8. Okay, let's see if we can do that. So that would be 1 divided by 5. And then for the first element, 2 times 5 minus 3 times 8. So that would be minus 14. And for the second value, that would be 15 minus 16. That would be minus 1. So the intersection point would be minus 14 divided by 5 and minus 1 divided by 5. And that's exactly the same point we found by using the elimination method. So you see, this is quite a convenient way to calculate your intersection point. Then as a last exercise, calculate the matrix 2c plus 3c minus 1. So c was this normal one. Let's put it down here. C would be minus 2, 3, minus 3, 2. And the c minus 1, that's this one, huh? C minus 1. Okay, so 2 times c would be minus 4, 6, minus 6, 4, plus 3 times the inverse matrix, so plus 3 divided by 5, and then 6 minus 9, 9 minus 6. Okay, I leave the adding for you. My sheet is running out of paper. Exercise 6. So give for each language 3 words. Well, language 1 contains all words with exactly 3 A's. So for instance, that would be A, or A, B, B square, or B, A, B, A. All sorts of possible combinations as long as there are 3 A's in there. Language L2, every letter is immediately followed with the letter AB. So we could have AB or AB, B, 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 AB, or even lambda, because then there is no letter A, so that automatically works, or only B's. Okay, so now we have an idea about the languages. Let's try to put them into a notation. So for language L1, a set notation. So we have 3 A's. So let's start by writing them. And then before or after these A's, we can have B's as often and as many as we like. And so we just fill up all empty spaces with B stars. L2, so every letter A is immediately followed with a letter B. So I need to have this combination. I can also have the combination with only a B, and then I can choose either one of them as often as I like. So as long as I have this combination, then I can at random do base and front or after or etc. A regular expression. Well, if we already have the set notation, then the regular expression is quite simple. So we have for language L1, let's call it R1, B star, A, B star, A, B star, A, and B star. Okay, and then for R2, and so we have the combination AB or B, and then we can choose as often as we like. And for the last one, we have to give a set notation for a language that consists of a combination. So the words of L1 and L2. So the set combination would just be L1 united with L2. And so this complete set notation united with that one. So L1 united with L2. And the combination regular expression would just mean we put an or in there. R1 or R2. Okay, that concludes the exercises week 2. If you have any questions, just let me know.